G'day viewers, and welcome to Introduction to Computer Networks. I'm David Weatherall, and I'll be your host for many of these video segments. In this first segment, we're going to talk about the goals and motivation for the course. Okay, so as you can see here in this figure, we're all familiar with using different clients which make use of the network. These clients then talk to our server computers across the other side of the network for some purpose, like using the web and so forth. What we have much less visibility into, because we can't see it directly, is what goes on inside the network. Well, that's precisely the focus of this course. Now, there are roughly 3 different kinds of courses you might think of as networking courses. At the lowest layer, communication courses look at how to send bits of information using signals. Building on this foundation, networking courses look at how to send packets of information across the network. And at the highest level, distributed systems courses look at how applications make use of the network. Our course is going to cover roughly this ground, which is to say we'll provide you with a classic networking course, but we'll also cover a little bit of communications and a little bit about how apps use the network, so you can see how all of these pieces fit together. We have 2 main goals for you in this course. The first goal is for you to learn how the internet works. When you do that, you'll gain a deep appreciation of, for instance, how what actually happens when you do something like simply use the web browser to look at a web page. There's a surprising amount of machinery which lies behind that simple application. Similarly, I expect many of you have heard of acronyms like TCP/IP, the DNS, HTTP, NAT, VPNs, 802.11, and so on and so forth. In this course, we'll tell you not only what they stand for, but tell you in detail how all of these different technologies work. Now, there are several reasons why you might care to learn about the internet. One is just curiosity. It's quite an astounding artifact in its own right. I'll talk about that in just a minute. A second is because of the impact that the internet has had on our world and continues to have. A third reason are job prospects. There is a lot of growth right now in engineering and computer science growths. Networking is definitely part of that. So understanding about networking in some detail is definitely good for your job prospects. So looking at the internet had very humble beginnings. It began as this small experimental network called the ARPANET around the beginning of 1970. This figure shows the evolution of the network topology, starting from a very modest 4 nodes in 1969, and then progressing as the topology becomes a little more complicated and nodes are added to this diagram. Here's a picture of the internet as it exists today, or around 2005. The internet has become an everyday institution. It's used at work, at home, on the go. We don't actually know what the topology of the internet looks like anymore. This picture is just a visualization using some of the best available data describing the internet. And it looks more like a star chart than any kind of network topology. This is the level of complexity we're dealing with these days. The internet has also had a tremendous impact on our society. Because of it, our society's actually changed and we do things differently than we would if we didn't have the internet. We now have easy access to knowledge with systems such as Wikipedia, whereas previously gathering knowledge used to be time-consuming or very expensive. We can easily participate in electronic commerce with systems such as PayPal, making electronic payments around the world. Even the way we meet people and stay in touch has changed with online dating services, as well as, of course, social networks to stay in touch with people. Different kinds of internet systems permit us to have discussions without censorship, systems such as Tor, even across international borders. And I guess that we could also add something like Coursera to this list, because the internet is changing the way we go about educating people in a pretty significant way. It's not just our society, but the internet has also had a tremendous impact on the economics of the world. It's really been an engine of economic growth. I've shown here just some examples of companies, and all of these big companies operate using business models which didn't exist before the internet, or they didn't really make sense without the internet. Google, for instance, provides advertising-sponsored search. That's its model for operating. It can do this because of the internet. Amazon is an online store, but it also operates by providing a long tail of inventory, something which isn't readily possible in a physical store. The internet also enables online marketplaces such as eBay, where clients and sellers can meet virtually before they conduct a transaction. And systems such as Amazon Mechanical Turk also allow us to crowdsource work by gathering a team of people in different places to perform a common set of tasks. Now, the second main goal we have for you in this network, in this course, is to understand the fundamentals of computer networking. By that, I mean that you'll gain an appreciation for the difficult problems that computer networks need to solve, as well as the design strategies which they use to solve these problems, design strategies which have proven useful over time. There are several reasons why you might care about learning the fundamentals. It's probably more difficult for you to see why you should care about learning the fundamentals of computer networking compared to simply finding out about the internet. But we believe that the fundamentals are valuable. First of all, they apply to all different kinds of computer networks. We might tell you how Wi-Fi works in detail and not really cover something like satellite networks, but all of the fundamentals you learn will apply to satellite networks as well. The fundamentals are also intellectually interesting in their own right. I'll give you an example in just a moment. And maybe the main reason why you should care is that the fundamentals are long-term knowledge, so they will help you understand the internet as it continues to grow and evolve and reinvent itself. Okay, here's an example of some of the fundamentals just to talk about the intellectual interest. One of the key problems in networking is reliability. A network needs to be able to deliver information reliably so that when you send a message to your bank, the message is delivered and it's the right message. It's not acceptable for the message to be garbled as it goes across the network so that your bank gets the wrong instructions. And it's also not acceptable for failures in the internet to unnecessarily delay your actions. Some parts of the internet will be may fail. In fact, some of them must be failed right now. Yet we expect the rest of the internet to continue operating. So how are we going to provide reliability given that parts will fail and messages will be corrupted? This is actually a very difficult problem because any machinery we add to provide reliability may itself fail. So you can see the quandary there. Well, fortunately, different solutions for reliability have been developed over time, and in particular we'll cover codes for error detection and error correction, which can help work out if there have been errors in messages and sometimes correct them. We'll also study routing techniques, which will identify failed regions and route around them if a path exists through working components. This table just shows you some of the key problems and different solutions that we'll cover during the course. I've talked a little bit about reliability, but that's not the only difficult problem or key problem in computer networking. There are also many problems to do with the growth and evolution of the network. Imagine designing a network that you want to allow to support applications you haven't thought of yet, and you also want it to allow it to grow by 6 or 9 or 12 orders of magnitude. That's quite a formidable problem. Imagine all of the bandwidth in the network and working out how we allocate that bandwidth and other resources to different users. The users who are using the network are always changing over time as people start or stop watching movies or surf the web and so forth. So it's very much a moving target. And finally, it's actually very difficult to design networks which are very open and easy to use for many purposes, which is key for innovation, but at the same time are hard to abuse, are secure in that sense. So we'll see some interesting problems there and solutions. All of the section numbers on the right here, they describe sections in your textbook where some of this material is covered. And so you'll see these sort of references coming up throughout all of the slides. If you're reading along, you can peek at some of those sections. Although this table covers, much of our book, so we'll have some more specific references later on. Okay, now one of the most important reasons to care about fundamentals is because they represent long-term knowledge, and that's important as the internet is being reinvented. We tend to think of the internet as it exists today, but actually it's constantly changing and being reinvented. It's grown tremendously over time, and technology trends have also changed. That's driven upheavals in the way we use the internet and hence the design of the internet. The upshot is that today's internet is different than yesterday's, and tomorrow's internet will be different again. This process of evolution is very much continuing. But the fundamentals remain the same, and they will help you understand the internet of tomorrow. Let me just give you a sense of some of that. This graph on the right shows the growth of the size of the internet in terms of the number of hosts. And you can see that it grew over a couple of decades from, less than 1 million hosts in the very early 90s to more than 1 billion hosts today. That's more than 3 orders of magnitude. I'm sure you're not surprised. We all know that the internet has grown tremendously. What you might not have the same appreciation for is that this growth has caused many different upheavals in the design of the internet. The emergence of the web, for instance, in the 90s caused a great increase in traffic, which led to content distribution networks, a new structure to more efficiently distribute information. The digitization of songs and videos, and their proliferation on the internet, led to yet another kind of distribution system called a peer-to-peer file sharing network, which really changed a lot of the internet traffic at the time. The falling cost per bit for sending messages across the internet has actually led to a lot of voice over IP calling, where traffic on the traditional telephone network is moving back onto the internet. The explosion in the number of hosts has stressed some of the internal internet protocols, and because of that, we're on the verge of really rolling out the deployment of a new internet protocol called IP version 6 inside the network. And many wireless advances have led to a great proliferation of mobile hosts. These hosts are somewhat different than traditional hosts. They move and still expect to have network connectivity, so that stressed the protocols in different ways. And finally, just to wrap up, I'll tell you one thing which is not a course goal, and that's to provide you with IT job skills, such as skills to configure a Cisco router, a la Cisco certifications. The reason we don't do that is because these skills tend to change frequently, whereas our goal is to provide you with long-term learning, which won't go out of date when the next router model comes out and the interface has changed a little bit. I don't want to give you the impression this is a purely academic course, however. A lot of the material you learn will be very relevant to your own experiences and understanding your home network, and we also provide you with experience with some hands-on tools to understand the internet.